Hi there, Samina. This is Kelly. I see page 2 here. Let's go ahead and go over this page together. Okay, so what I notice is the first thing we're told is that the triangle ABC, so ABC is congruent, that means equal measure to triangle HIJ, HIJ. And it wants us to solve for both X and Y. Okay, so what you need to know, let's take a close look at this, is that side AB corresponds to side HI. If they're congruent, that means they are of equal length. So we know first thing that the distance of AB is equal to the distance HI. And if that's the case, then this 15 is equal to this X plus 10. Then from here, it's a matter of simply solving for the X by itself, which in this case, X would equal 5. So the key to this is knowing that the triangles are congruent, which means equal measure. Another thing you're going to notice, it says that angle C is in the same position as angle J. It's just rotated, C and J. That means that the measure of angle C is going to equal the measure of angle J. So in this case, we have 45 degrees equals Y plus 5. So we minus 5 both sides. And of course, we get Y equals 40. So this symbol here is what's so important, is the fact that it means those triangles are equal. And you must correspond. A corresponds to H, B corresponds to I, and G corresponds to J. Once again, down here, we're told to find the value of X and Y. And what we notice is we have two congruent sides. One congruent side with the one hatch mark, and two congruent angles. And if we have the same information as we do up here, which I'm assuming we do, we can assume that triangle ABC is congruent to triangle Okay, now the way you have this marked, this is really important, the way it's been marked, okay? Notice right here we have one hatch mark, two hatch marks, two hatch marks. So the order's changing because you have to align those hatch marks if you drew these correctly. But if it's, I think your hatch marks are in the wrong place, Samina, because if it's the same problem from above, triangle HBC should be congruent to triangle HIJ, which let me take a closer look at your diagram. Okay, what I'm noticing here, Samina, let me just make sure I understand this correctly. This looks like 85 degrees to me. And if it is, then the 85 degrees corresponds to here. And if you have the double hatch mark here, that double hatch mark corresponds to 35 degrees, which means the 35 degrees also comes over here. That's what those hatch marks mean. So if that's the case, if those are both 85 and those are both 35, then this, you can add 85 and 35. We're going to add them together, and we get 120 degrees. Remember I told you that triangles add up to 180, so we're going to do 180 minus 120. That means our third angle for both of these has to be 60 degrees. And on the left-hand side, that means x equals 60 degrees. And on the right-hand side, y plus 10 equals 60 degrees. So y will equal 50. If you've drawn that correctly, that's what those hatch marks mean. I'll recap. What this means is this one hatch mark angle is the same as that one hatch mark angle, so 85 equals to 85. The double hatch mark matches with this double hatch mark. So we added 85 and 35, and we got 120. Because that's 10, carry the 1. Got 12, 120. We take 120 away from 60. That means that third angle must be 60 degrees. Therefore, x equals 60 and y plus 10 equals 60, so y equals 50. Okay, in the next one, Samina, I come back here. It asks, what is the included sides for AB, included angle, that's an important included angle, for sides AB and AC. So here's AB, and here is AC. The included angle means the angle that's squeezed between. So the included angle means when we're talking about one side and another side, we say that word included angle to be the angle in between, which in this case is angle number 1. Alrighty, this last problem, there are 4 ways that triangle can be made to be equal. 4 ways. Okay, this is a much involved lesson. I'll try to make it a shortcut. One of the 4 ways is that you have a situation where all the sides are congruent. One side, another side, and a third side. That's called side, side, side. Then another situation would be where, for example, you have a pair of sides and then a pair of congruent angles and then another pair of congruent sides. And this would be called side angle side. A third one would be is if you have a pair of angles, a pair of sides, and another pair of angles. This is called angle, side, angle. And the last one is if you have a pair of angles, another pair of angles, and then a side. This is called angle, side, side. Excuse me, I take that back. Angle, two angles, and then a side. So the four ways triangles can be made congruent, the four shortcuts, if you will, are side, 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 angle, side, angle, side, angle, or angle, angle, side. In this case, we are given the fact that we have a pair of congruent sides, and here we have another pair of congruent sides, and then always vertical angles are always congruent. So in this case, this shortcut is side, angle, side. So yes, the triangle ABC is congruent to DBE by the shortcut side, angle, side.